Hey VDSers, I wanted to share with you how we would dilute our GBlocks and our primers. Usually we receive our GBlocks and our primers in an envelope like this from IDT. And then for each of our GBlocks, we also have a data sheet. So here is the packaging list, which shows us the 1, 2, 3, 4 GBlocks that we've received. And they're all different base pairs in length and different amounts in each tube. So I've already done, so this is the specific sheet for SA-DHFR, so Staphylococcus aureus DHFR. Here's the full sequence of that G-block, double-stranded DNA. It tells us how much is in here, 500 nanograms, and that the length is 480 base pairs. Here are the instructions for G-blocks. We need to resuspend the G-block by centrifuging the tube at 3000 G to ensure that the material's at the bottom of the tube. So I'll demonstrate that actually with the primers because I've already done that on the G-blocks. We need to add TE to reach a final concentration of 10 nanograms per microliter. So if I have 500 nanograms here, I would need to add 50 microliters of TE to give me 10 nanograms per microliter. After adding the TE, I vortex briefly, then I'm going to incubate at 50 degrees for 20 minutes, so I'll show that in a second. And then we would briefly vortex and centrifuge again. So that's how we prepare our G-blocks. This is a TE buffer. So I know that this buffer EB is actually TE buffer, or tris EDTA. There's tris in there for pH buffering, and then EDTA for chelating metals so that nucleases don't degrade our DNA or RNA, whichever we have. If I'm not sure what's in here, I could go look at the catalog number and search online and find out if this has EDTA or tris or what is in this elution buffer. But I know that this is TE buffer. Okay, so I've already spun down in the centrifuge. I've already added the TE to each sample, and then I've marked on the top of the tube that it's 10 nanograms per microliter of TE, and I've marked on the side of the tube the same thing. I'm going to check, we're going to look here on our thermometer, and it's right at 50 degrees. And the way that we get that set up is there's a low and a high setting on this, so we've turned it to low. I've rotated this dial. I just keep shooting until I get to somewhere around 50. Until I'm going to set that 50 degrees C. So after letting it search for a while, it's finally gotten to that point. So I'm going to set these in there, and I run that for 20 minutes. So just in case I forget, I'm going to write down the time. Okay, the next step is we're going to look at our tail primers. So we received these in the same kind of envelope for the tail primers. Actually, these are the wrong sheets. Tail primers are actually right here. So we have a packaging list. We have two tail primers for each target. This is for the PF6PGDH, the YPD-ALAs, the DHFR forward and reverse, and the Staphylococcus aureus DHFR forward and reverse. So these are 25 nanomolar DNA oligos. Here's the spec sheet for each individual one. So this is for the insert forward pipe SA-DHFR primer. Here's the length of the primer. This is single-stranded DNA. It tells us how many nanomoles we have, and then it conveniently tells us for 100 micromolar concentration, I would need to add 309 microliters. I always want to make sure and spin these down beforehand, so we'll go over to the centrifuge. So the G-block recommended setting a speed of 3000 Gs. So I'm just going to do the same for this. And then I'm not going to run it a full 2 minutes like I did for the G-blocks. I'm just going to hold pulse and run it until it gets up. This is actually going to go to high. When I do pulse, it just goes to max speed. And I just hold that for 10-15 seconds. And that should be sufficient. For the GBlocks, we only ran it up to 3,000 because that was the recommended speed. Okay, so now we head back over here. I've just taken them out of the centrifuge, so I want to make sure I have them in the right order. This is ends forward pipe SADHFR. And I always like to have them set in my block here, and then as I add something, I move it one row down the block. So I need to add 309 microliters. This is a 200 microliter pipettor, so I can't add the full amount with one shot. So what I'm going to do is I'm going to add 2 shots. So 309 divided by 2 is 154 and a half, I believe. So I'm going to set my pipettor to this, 154.5, and I'm going to lock it in. And then I'll do 2 pipette amounts here. I could use the larger 1000s, but I don't think it'll be as accurate as doing 2 shots of this. Close my stock when I'm done with it, and then I move this to the bottom well because I've finished adding the amount that I need to add. So I'll do the same thing for this last primer I need to dilute. I also want to make sure and write on here that this is 100 micromolar. So I can write on the end of the tube 100 micromolar. Comes into focus at all. And then I'm going to write on the side of the tube the same thing, and then put VDS on there as well. And then when we're writing micro, so what I wrote on the tube was this, micromolar. So this lambda symbol is a good way, is better than writing M for micro, the mu, because sometimes the N and the M can get confused. So if we write micro, or lambda, that means micro. Okay, so now I've added this. I'm probably gonna vortex briefly here. Vortex that, and then I want to make sure I'll probably spin it again just to be safe. For the big one, I could do this in the bubble spinner, but this one's hard to open, so I'm not going to do that. Make sure they're balanced. And then I'll just do pulse. A couple of seconds of spin. So now I have my primer to dilute it. I've spun it down, and then now it can go into our fall FRI VDS Fall 2020 GBlocks and tail primers box. Put it here, and then we'll walk over to Julio. And set it in the fridge. Or the freezer. Okay, hopefully that was helpful. See you guys in wet lab and in the virtual